Good day, everybody. This is a continuation of the regression recorded lecture that you heard before this one. We're going to show an actual example of what you'll be doing in the critical thinking exercise for Module 2. We're going to go through a very similar example using similar data, and we're going to go step by step through the regression analysis procedure. What I'm showing you here is a Word document of screenshots of the different steps that we're going to go through in the next 10 or 15 minutes. You can download and print this so you have it next to you as you're going through the actual regression analysis. Hopefully what I'm doing now should mirror what's on this series of screenshots. This is the sample data we're going to be using for our practice example right now. If you look at the critical thinking exercise in the regression module, Module 2, you'll see similar looking columns, only they have different titles. For the critical thinking exercise, I'm using population as the independent variable and the number of auto sales. Annual auto sales in America as the dependent variable. In this example, the dependent variable is lifetime earnings, and I'm saying that depends upon the independent variable years of education. Let's begin this, however, with a required part of the assignment and draw a scattergram or a scatter graph. I'm highlighting the headings and the data. I'm going to insert. I'm going to this little scattergram icon and pick the top one on the left. So here's a scattergram of my data. The dependent variable, the Y variable, is the lifetime earnings. That's the vertical axis. And the independent variable, the X variable, is on the horizontal axis. And I would like you to put a trend line in. So at least for this computer, click the plus sign, and I could put in a trend line. Okay, so that's one part of the assignment. Now let's go to the actual regression.
Hello, this is Adam with Instructional Technology, and today we're going to get your Excel set up so that you can have your data analysis set up in the Data tab. Sometimes it will be turned off by default, so here's the quick way that you can get that set up. What you want to do is open up your Excel. You'll click at File in the upper left-hand corner. You'll have a few options that come up, but what you want to do is get to Options at the bottom. If you have an older version of Excel, it may just be the Windows button. Same thing as clicking on File. Once you get down to Options, click on Options, and a pop-up will appear. You're going to want to go down to Add-ins. Once you click on your add-ins, you're going to see all the various available add-ins that are available part of the package. So you'll notice right now under an inactive application add-ins, we have this Analysis Toolpak VBA. So what you want to do is you want to hit the Go button, that's down at the bottom there, and it's going to give you the available add-ins that you can turn on. So I'm going to go ahead and click the checkbox for Analysis Toolpak and Analysis Toolpak VBA, and I'll go ahead and hit OK. And that's going to turn those on, and now when you go to your Data tab, you'll have your Data Analysis button that's right in your window. So I'm going to go ahead and pass it off and let you learn a little bit more on economics.
The last video, Adam, one of our technical experts in instructional technology, showed you how to access the data analysis application. Click Data, and over on the right is the data analysis application. We get a menu of about 15 different kinds of statistical analysis. We're going to be using the regression analysis. So let's click OK. First thing it asks us is for the Y variables range, the cell range for the Y variable. The Y variable is the dependent variable. So I'm going to tell Excel the dependent variable is between C2 and C16. I don't know if I better write it, C2 through C16. The x variable, which is the independent variable, is B2 to B16. I want a 95% confidence interval, and I want my output to go on a new worksheet. So when I click OK, we're going to see a new tab down here with the regression output. We don't have to worry about any of this stuff down here. Okay, on sheet 2 is where it ends up, a new sheet. Let's expand the columns. And let me highlight what was in my prior PowerPoint and what's in the critical thinking assignment. Now, I already have arrows drawn. Hold on for a second. Here it is. So I already have arrows drawn on what you need to comment on. I'm going to go quickly through these. A more thorough explanation is in the PowerPoint. Let's start at the top. The adjusted R-square is the percent of variation in the dependent variable attributed to variation in the independent variable. So you'd like this number to be pretty high. The way I interpret this, a little over 81% in changes in lifetime earnings is correlated with, can be attributed to, can be predicted based on the years of education. That's a pretty good number, 81%. The actual regression formula that you have to write out requires these two numbers here. The intercept, or what is sometimes called a constant, is the value of the independent variable when the dependent variable equals 0. So the way to interpret this, I'm afraid, is if you have no education, your income will be minus $328,000. And we know that makes no sense whatsoever. I attribute that to the fact that look at the lowest years of education. I have 5, I have 4. I have very few data points way down here, which means simply extrapolating this line loses its validity very low down in the data. That's what I'd attribute that to. Obviously, if you have 0 years of schooling, you can still find some unskilled job that pays you something. So we know that the intercept of minus $386,000 is a meaningless number in this example. The more important number is the 57.5. For every additional year of education, the regression model would say your lifetime earnings will go up by 57.5 thousand. That's how you'd interpret that. The p-value of these two coefficients, the intercept and the x-coefficient, the p-value basically tells you what's the probability, statistically speaking, that the coefficient is really 0, or that this coefficient is really 0. This is a probability kind of result. It looks like in both cases the probability is very, very small. Remember, e to the minus 06 is scientific notation. Both of these numbers are very, very small. So we can probably be pretty sure that neither of these is in fact 0. When these p-values are low, it adds credibility to those coefficients. Taking a similar approach to the entire regression formula is what's called the significance of the F statistic. If this number is very small, it's saying the probability that all the coefficients together at the same time are 0 is very, very small. If that significance of the F statistic, if that number was a pretty high number, 10%, 20%, 30%, you would take your entire regression analysis and throw it in the garbage. Because that's a very small number, because these are pretty small numbers, we're confident that these two figures, either alone or together, are not equal to 0, and a regression formula has some validity. The actual regression formula you would type out would look something like this, and this was in my PowerPoint in terms of format. Y, the dependent variable, lifetime earnings, equals minus 328, we're not going to worry about the decimal, plus 57.5 times X. X is the years of education. Y is the dependent variable, the lifetime earnings. I would call this the regression model or the regression formula. And that's the format you would put your answer in as for one of the questions in the critical thinking module.